So for number 1 in part 2, the question, there's an A and a B. So for A, it's asking to evaluate the limit of, well, let me just write this down. Evaluate the limit of t going to 2. It's going to be t squared over 4 over t cubed over 8. Alright. So to find the limit, you're first going to try to factor everything. So you're going to end up factoring the top. You're going to end up with t minus 2, t plus 2, and when you factor the bottom, using the difference of cubes, which, well, I should probably write in the top the difference of squares too. Yeah, probably not. It's kind of common sense by now, but I always have trouble with the difference of cubes, which is, I'll write it down here. It just kind of helps me. A minus b, a2 plus ab plus b squared. Alright, so then you're going to end up with t minus 2, alright, t squared plus 2t plus 4. So already you can see that you can cross out t minus 2 on the top and on the bottom, and you're going to be left with the limit t going to 2. You're going to be left with t plus 2, and you're going to be left with this big thing down here that you cannot factor. So you're just going to plug in 2 to here, so it's going to be 2 plus 2 over 2 squared plus 2 times 2 plus 4, and equals 12, and you're going to be left with, after you simplify it, 1 over 3. For part B, the question is asking, consider the function f of x equals x squared plus 5x plus 6 all over x plus 2. At what point is f discontinuous? Find the limit as x approaches the point of discontinuity. Alright, so let me go ahead and write this big guy down. Plus 5x plus 6 over x plus 2. Okay, so you can kind of tell it's kind of obvious. I had a big brain fart during the test, but the point of discontinuity, I can't say that, is going to be -2, because when you do -2 plus 2, it's going to be going to 0. So, and you cannot have 0 at the denominator, so that's where the function discontinues, is going to be -2.